Welcome back. In this video, we are going to talk about how to look inside a chemical formula to count the moles of individual elements. We've already learned how to weigh a whole mole of a substance, but now we need to understand how many moles of carbon or hydrogen or oxygen are tucked inside that one larger unit, like a molecule. You could think of a chemical formula like a car. If you have one car, you know you have 4 wheels. And if you have a dozen cars, you have 4 dozen wheels. Similarly, if a molecule has a subscript of 4 for hydrogen, then 1 mole of that molecule contains exactly 4 moles of hydrogen. So this is a molecular model of methane, CH4, and the 4 is what we call a subscript, telling us we have 4 hydrogen atoms in that molecule. Let's look at glucose. Its formula is C6H12O6. Just by looking at the subscripts, we can determine the internal recipe. 1 mole of glucose contains 6 moles of carbon, 12 moles of hydrogen, and 6 moles of oxygen. It's that simple. Now let's try a test question. If we have 2.00 moles of this substance, how many moles of hydrogen do we have? I included a molecule here, but we don't really need to look at that. We have the formula H3PO4. We're interested in the hydrogen. Since the subscript for H is 3, we simply multiply our 2.00 moles of the compound by 3 to get 6.00 moles of hydrogen. We ignore the 4 because that's for oxygen, not hydrogen. What about phosphorus? There is no subscript for capital P in the formula H3PO4. This means there's an invisible 1. So for the 2.00 moles of the total substance, we have exactly 2.00 moles of phosphorus. Now that you see how this works, try to calculate how many moles of oxygen are in 2.00 moles of H3PO4. Be sure to write your work with the units and the final answer.